Welcome you all in the lecture number 9 of Engineering Mathematics 1 MTL 1025. In this lecture, we will going to discuss what are the asymptotes, types of asymptotes, for example rectangular asymptotes and oblique asymptotes, what are the method of finding the rectangular asymptotes and what is the method of finding the oblique asymptotes, right? Now first see what is asymptotes. And asymptotes is nothing but it is a straight line, right? It is a line that approaches closer to a given curve as one or both of the x or y coordinate tend to infinity. For example, this is the curve, right? This is the curve, and this straight line, it seems that this straight line will touch the curve, but it never touches the curve. This curve go in this way and a straight line in this way, right? This straight line touch this curve at infinity. If any straight line touch a given curve at infinity, it seems that it will touch, but it does not touch the curve. And if it touch at infinity, then this type of a straight line is known as asymptotes of the curve, right? There are two type of asymptotes. One is rectangular and one is oblique asymptotes. What is rectangular asymptotes? An asymptote is said to be rectangular if it is parallel to either of the coordinate axis, whether it is parallel to x-axis or y-axis, right? Then it is known as rectangular asymptotes. If the asymptotes is not parallel to x-axis or y-axis, then it is known as oblique asymptotes, right? What are the method of finding the rectangular asymptotes and oblique asymptotes? Let us see by the example. What is oblique asymptotes? That the asymptotes which is not rectangular asymptotes is known as oblique asymptotes. That is, asymptotes neither parallel to x-axis nor y-axis is known as oblique asymptotes. Now, what is the method of finding the rectangular asymptotes? To find the rectangular asymptote, since we know that rectangular asymptotes is either parallel to x-axis or parallel to y-axis. If the rectangular asymptotes parallel to x-axis, then we can find it by equating the coefficient of highest power of x is 0, right? It will gives us the asymptotes parallel to x-axis. Similarly, if the asymptote is parallel to y-axis, then we can obtain it equating the coefficient of highest power of y equal to 0, right? See the example. The equation of curve is given by 4x square plus 9y square equal to x square y square. Now we have to find out the asymptotes, whether it is rectangular asymptotes or oblique asymptotes. Let us see. First we have to find out the rectangular asymptotes. In rectangular asymptotes, we know that coefficient of highest power of x is 0, right? And coefficient of highest power of y is 0. What is coefficient of highest power of x? Write this equation as follows. 4x square 9y square x square y square equal to 0. This is x square 4 minus y square equal to plus 9y square equal to 0. Now coefficient of x square is 4 minus y square. This is 0. What is y? Y is equal to plus minus 2, right? This is the asymptotes. The asymptotes parallel to x-axis. Now asymptotes parallel to y-axis, coefficient of highest power of y equal to 0. Now this equation can be written as again y square 9 minus x square equal to 0, and this gives us 9 minus x square equal to 0, and this gives us x is equal to plus minus 3. Okay, then there are four asymptotes. Y is equal to 2, y equal to minus 2, x equal to 3, and x equal to minus 3. These are the four asymptotes right? 4 rectangular asymptotes. Now, what is the method of finding the oblique asymptotes? Let us see. The method of finding the oblique asymptotes are as follows. What is asymptotes? Asymptotes basically a straight line, right? What is equation of a straight line? Y is equal to mx plus c, right? Then there are two parameters. One parameter is m, another parameter is c. If we are able to find out the m and c, then we know the equation of a straight line, right? That we know the equation of asymptotes. What is the method of finding m and c? Let us see. For any equation of curve, we have to arrange it as follows. Phi n xy, phi n minus 1 xy, dot so on, phi 1 xy plus constant term k is equal to 0, right? What is phi n? Phi n xy means, phi n xy, it means, right, highest degree or nth degree, highest degree or nth degree term, nth degree term. For example, suppose this curve is given x cube 3x square y plus y cube minus x square minus 2xy plus y square plus 2x plus 3y plus 2 equal to 0. Suppose this is any curve. I have written a general equation. Then what is phi n? What is the highest degree term? Highest degree is 3, right? Then n is equal to 3. Phi 3xy. Phi 3xy means all the third degree term. This one, and this one. These three are the third degree term. That is, phi 3xy is x cube 3x square y plus y to the power 3, right? Now, what is phi 2xy? Phi 2xy is all the second degree term, right? Minus x square minus 2xy plus y square. This is phi 2. What is phi 1xy? First degree term, 2x plus 2y, right? Then in the equation 1, phi n represent the highest degree or nth degree term. N minus phi n minus 1 exy represent n minus 1th degree term, and phi 1 exy represent first degree term. And k, what is k? K is constant, right? Then we will adopt to evaluate the oblique asymptotes. We will evaluate the following step. We will see the following step, right? What is step 1? Putting x is equal to 1 and y is equal to m, right? What is x? X equal to 1. What is y? Y is equal to m. Where in phi n xy, phi n minus 1 xy and phi 1 xy, it means in phi n minus 1 up to phi 1, right? Everywhere x equal to 1 and y equal to m. This is the step number 1. What is step number 2? Equating phi and m is equal to 0, right? If we put x is equal to 1 and y equal to m, then this phi n becomes phi nm 0, right? Now, solving this phi nm 0, solving this, we find m, right? We find m. If we find m, we already discussed that there are two parameters in y is equal to mx plus c. Now we find m here, right? In step number 2 we find m. What is the procedure of finding c, right? there are many cases arise. What are the cases? If we evaluate m, suppose m in third degree equation, suppose m is equal to 1, 1 and 2, then these two roots are repeated, right? 1 is repeated and 2 is not repeated root. For 2 we can obtain different formula, and for repeated root we can use different formula, right? See, if m is non-repeated root, what is m? M is not non-repeated root, right? Just like 2. Then in this case we have to use this formula. What is the formula? C phi n dash m plus phi n minus 1m is equal to 0, provided the condition that phi n dash m does not equal to 0 for this m, right? For this type of m, this is not equal to 0, right? If phi n dash m is equal to 0, it means there is no asymptotes of the curve corresponding to this value, right? Okay. Now, if what happen if the roots is repeated 2 times, right? If root is repeated 2 times, then what is the formula for obtaining c? C square by factorial 2 phi n double dash m plus c by factorial m, 1 phi n minus 1m, right, dash, and phi of n minus 2m is equal to 0. But condition is that phi n double dash m does not equal to 0, right? But if m repeated 3 times, 1, 1, 1, then what is the formula for finding c? Right? Write in this way. C cube by factorial 3 phi n triple dash m c square by factorial 2 phi n double dash m c by factorial 1 phi n minus 1, phi n minus 2 dash m plus phi n minus 3m is equal to 0, right? Similarly, if m repeated root 4 times, then c4 by factorial 4 phi n 4 dash m plus c cube by factorial 3 phi n minus 2 triple dash m plus c by factorial 2 phi n minus 2 double dash m and c by factorial 1 phi n minus 3m dash plus phi n minus 4m is equal to 0, right? Now from these equation we get c, right? Evaluate c. Now you know c, you know m, putting the value y is equal to mx plus c, we get the asymptotes, right? Now let us see some example how to evaluate oblique asymptote. See, find the asymptotes of the curve. Only it is given, find the asymptotes of the curve. Not mention that oblique asymptotes are rectangular asymptotes. Then first you have to check the rectangular asymptotes. For rectangular asymptotes, coefficient of highest power of x equal to 0. This will gives the asymptotes parallel to x-axis, right? Okay. See the equation. See this equation. What is the coefficient highest power of x? Highest power of x is 3. What is highest degree term in x, that is x3. What is its coefficient? Its coefficient is 1, right? Its coefficient is 1. Equate this 0. 1 equal to 0? No, this is absurd, right? It means this curve has no asymptotes parallel to x-axis. Similarly, coefficient of highest power of y. Highest power of y is 3, right? What is its coefficient? Its coefficient is 1. 1 equal to 0. This is absurd, right? It means there are no asymptotes parallel to x-axis or y-axis. It means this curve possesses no rectangular asymptotes, right? Then, if this curve possesses no rectangular asymptotes, then what happens? We have to find oblique asymptotes. Now let us see for oblique asymptotes. For oblique asymptotes, collect the all third degree term, right? What is third degree term? Phi of 3xy. Phi of 3xy, third degree term is x cube x square y minus xy square plus y cube, right? Now, what is phi 2xy? Second degree term. 2x square minus 4y square plus 2xy, right? Now, what is first degree term? Phi 1xy. This phi 1xy is equal to x plus y, right? Then this is phi 3, phi 2 and phi 1. This is step number 1. Now, step number 2. For step number 2, what we have to do? Phi 3m. It means x equal to 1 and y is equal to m. This is 1 cube minus x square y 1 square into m 1 square into m minus 1 into m square plus m cube. It means m cube minus m square minus m plus 1, right? This is phi 3m, and phi 2m is equal to, this is 2 minus 4m square plus 2 1 into m, and phi 1m is equal to x plus y. X is equal to 1 and y is equal to m. This is phi 3, phi 2 and phi 1m, right? What is the value of m? Value of m, that is phi 3m is equal to 0. This gives m cube minus m square minus m plus 1 is equal to 0. Solve this third degree equation. We got the roots of this equation. It means m is equal to 1 1 and minus 1. This gives m is equal to 1 1 and minus 1, right? This. Now here two cases arise. Number 1, minus 1 is non-repeated root and 1 is repeated roots, right? Now for m is equal to minus 1, that is non-repeated root, how we obtain the corresponding value of c? The corresponding value of c can be obtained by this formula: c phi 3 dash m plus phi 2m is equal to 0. Now c, what is phi 3m? Phi 3m is equal to m cube minus m square plus 1. What is phi 2m? This is equal to 2 plus 2m minus 4m square, right? Phi 3 dash m. This is equal to 3m square minus 2m minus 1. Now phi 2m is equal to phi 2m is same. Now putting these two values here and m is equal to minus 1. Then see phi 3 dash m, that is 3m square minus 2m minus 1 plus phi 2m. Phi 2m is 2 plus 2m minus 4m square. Okay, equal to 0. Now putting m is equal to minus 1. Then see 3 plus 2 minus 1 plus 2 minus 2 minus 4 equal to 0. This implies that c is equal to 4 by 4, that is 1. Then what is y is equal to? Mx plus 1. What is m? M is equal to minus 1 into x plus c. That is y is equal to minus x plus 1, or x plus y minus 1 equal to 0. This is the one asymptotes, right? Now what is the other roots? M is equal to 1 is the repeated root, right? 1 is equal em is equal to 1 is the repeated root. What is the formula for evaluating c? C can be evaluated by this formula: c square by factorial 2 phi of 3 double dash m plus c by factorial phi 2 dash m plus phi 1m is equal to 0. Now we know everything. What is phi 3? Phi of 3 is equal to m cube minus m square minus m plus 1, right? What is phi 2? Phi 2 is 2 plus 2m minus 4m square. What is phi 1? 1 plus m, right? Differentiating and putting all the values here, then we obtain c square by factorial 2. Double derivative of phi 3, right? First derivative is 3m. First derivative is this. What is double derivative? 6m minus 2 plus c by factorial 1 phi 2 dash, differentiating this, that is 2 minus 8m, right, plus 1 plus m is equal to 0, right? Putting m is equal to 1 and solving this quadratic equation in terms of c, then c square minus 3c plus 1 is equal to 0. What is c? C is equal to this one, right? Then what is the equation? Y is equal to mx plus c. What is m? M is equal to 1. Then y is equal to 1 into x plus c. One time here, one time this one, and second time y is equal to x plus 3 minus root 5 by 2. Then this curve have three asymptotes. One is this, second is this, and previous one is x plus y minus 1 equal to 0, right? See another example. Find the asymptotes of the curve. This curve is fourth degree term. Then you have to collect phi 4, phi 3, phi 2, phi 1. What is phi 3? Phi 4. Phi 4 fourth degree term. Y 4 2xy cube 2x cube y x4, right? And phi 3 is third degree term. Minus 3x cube 3x square y 3xy square 3y cube. And phi 2 second degree term. And phi 1, no phi 1 term. First degree term is not present in the equation. Then phi 1 xy is equal to 0. Now, what is first step? Putting x is equal to 1 and y is equal to where? In phi 4, phi 3, phi 2 and phi 1. Phi 1 is 0. So, no problem. What is phi 4m? Phi 4m, y is equal to m. m4, 2m cube plus 2m minus 1. What is phi 3? Putting x is equal to 1 and y is equal to m. Minus 3, 3m, 3m square minus 3m cube, right? And phi 2m minus 2, and this is 2y square, not x square. Then 2m square, and no first degree term, therefore phi 1m is 0. Now find the root. Find roots by equating this equation. Phi 4m is equal to 0. What is phi 4m? m to the power 4, 2m cube plus 2m minus 1 equal to 0. That is m3 m minus 2 no, not in this way. We have to evaluate some other. See, equate this term is 0. That is, this is something like m minus 1 cube into m plus 1 is equal to 0. Then m is equal to 1, 1, 1 and m equal to minus 1. This is non-repeated root and this is repeated 3 times, right? Then for m is equal to minus 1, m equal to minus 1, what is the formula? C phi 3 dash m, sorry, phi 4 dash m plus phi 3m is equal to 0. Then C can be written as minus phi 3m divided by phi 4 dash m is equal to and m is equal to minus 1, right? Then C is equal to phi 3m, that is minus 3 minus m cube plus m square plus m minus 1 divided by phi 4 dash m. This is phi 4, right? Or this is phi 4. Differentiate this. Differentiating this term will give us 3 into m minus 1 square m plus 1 plus m minus 1 cube, right? M, what is m? M is equal to minus 1. Putting m is equal to minus 1, right? Putting m is equal to minus 1, minus 3 minus 1 cube, that is plus 1. This one is minus 1 square plus 1. This is minus 1 and minus 1, right? This is 2 and minus 2. This term is 0. Numerator is 0. And what about the denominator? 3 minus 1 minus 1 minus 2 square minus 1, and this minus 1 plus 1 plus minus 1 square. This is 0 and this one is 4, 0. This is 0, right? Then C is equal to 0. What is equation? Y is equal to mx plus c. Mx plus c. What is m? M is equal to minus 1 minus x. What is c? 0. Y is equal to minus x. That is x plus y is equal to 0 is the one asymptotes corresponding to m is equal to minus 1. Now m repeated 3 times, 1, 1, 1, right? Then if m repeated 3 times, then we have to use this formula, c cube by factorial 3 phi 4 double dash m, right? Phi 4 triple dash m, sorry, triple dash m, c square by factorial 2 phi 3 double dash m, c phi 2 dash m plus phi 1 m is equal to 0. Now c cube, differentiating phi 4 3 times, we got this. Phi 3 2 times, we got this. And c into phi 2 dash, phi 2 one time with respect to m, and phi 1 m is already 0. Putting m is equal to 1 and finding the value of c, right? Then c can be given by 0, 1 and 2. Now the equation is y is equal to mx, 1 into x plus 0. Y is equal to 1 into x plus c1, and y is equal to 1 into x plus 2. This equation and this equation, right? These are the asymptotes, and one previous asymptotes, that is y is equal to minus x. Similarly, we can use another example, this example. Now highest degree term is 3 and second degree term is this, first degree term is this. phi 3m is equal to, putting x equal to 1 and y equal to m, right? Then 1 minus m square, 1 plus 2m. What is phi 2m? Phi into x is equal to 1 and y equal to m, 1 plus m square. Phi 1m, x equal to 1 and y equal to m, 1 plus m, right? Now evaluate phi 3m is equal to 0. Phi 3m, that is 1 minus m square, 1 plus 2m. Then m is equal to 1 minus 1 minus 1 by 2. All are distinct. Okay. Now c can be written as minus phi of 2m divided by phi 3 dash m, right? And putting m is equal to 1 minus 1 minus 1 by 2 respectively. We find c. See, phi 2m, phi 3m, phi 3 dash m. Now m is equal to 1, c is equal to this. Then equation of a straight line is y is equal to mx plus c, and y is equal to 1 into x plus 5 by 3. Similarly, for m is equal to minus 1, c is minus 5 by 3. For m equal to minus 1 by 2, c is equal to minus 25 by 6. Right? Then the equation of asymptotes is given by this. Now, see some exercise. Right? There are 5 problems. You solve these 5 problems. If you have any doubt in any problem, then we will discuss in the online class. Okay. Okay. Thank you.